On the morning of June 6, 1944, George Hyde was living in Dayton, Ohio, where he worked as the chief gun designer for the Inland Division of General Motors. 3,000 miles away, across the Atlantic Ocean, the largest amphibious invasion in human history was about to begin. Hyde did not know this yet. Nobody in America did. The news would not reach civilian ears for several more hours. Hyde was 56 years old. His hands, once steady enough to machine gun parts to tolerances measured in thousandths of an inch, now trembled slightly when he held his morning coffee. He had been born on January 4, 1888, in a small village called Opfingen, near Freiburg, in what was then the German Empire. He had learned the machinist's trade as a young man. He had designed weapons for the German military during the First Great War, and now, in his adopted country, weapons he had designed were about to be carried into battle against the nation of his birth. The irony was not lost on him. Hyde had immigrated to the United States in 1926, following a path that millions of others had taken before him. His family followed a year later. He had arrived with little more than his skills and his ambition. He had changed his name from Hyder to Hyde. He had found work at Griffin and Howe, a prestigious gunsmithing firm in New York City, where wealthy Americans brought their sporting rifles to be customized and repaired. He had married a German woman named Margareta, whom everyone called Greta. They had 2 children, a son named George Jr. and a daughter named Giselle, both born in Germany before the family immigrated. Hyde had become an American citizen. He had built a life in this new country. But he sometimes wondered what had become of the men he had known in Germany, the other machinists, the engineers, the workers in the weapons factories. Were they still alive? Were they still building weapons for the German military? Would one of them be killed by a weapon that Hyde himself had designed? These were questions that had no answers. What Hyde did not know, on that June morning, was that at that very moment, young American paratroopers were checking their equipment one final time before jumping into the black skies over Normandy. Many of them carried a weapon Hyde had designed, a weapon that cost the United States government just over $20 to manufacture, a weapon that some soldiers had called a piece of junk and others had called a masterpiece of industrial efficiency. They called it the grease gun, and in the next 24 hours, that cheap, ugly, stamped metal submachine gun would help change the course of the war. The story of how a German immigrant created a $20 weapon that made German engineering irrelevant begins not with Hyde, but with a problem that had plagued the United States Army since the moment it entered the war. The problem was the Thompson submachine gun. The Thompson was a beautiful weapon. It was crafted from forged steel with milled parts and fine walnut furniture. The metal surfaces were polished and blued to a deep black finish. The action was smooth and precise. Every part fit together with the kind of tolerance that only skilled machinists could achieve. It had been designed by Brigadier General John Thompson during the First World War as a trench broom, a close-quarters weapon that could sweep enemy soldiers from their positions like dust from a floor. The Thompson had gained fame in the hands of gangsters during Prohibition, carried by men like Al Capone and John Dillinger. The distinctive drum magazine and the intimidating sound of its automatic fire had made it an icon of the lawless 1920s. Hollywood had immortalized it in countless films. American soldiers loved it. They called it the Tommy gun, and they fought to be assigned one. But the Thompson had a fatal flaw. It was expensive. Obscenely, absurdly, catastrophically expensive. In 1939, when the Army began preparing for the possibility of war, each Thompson submachine gun cost the government $209 to produce. That was equivalent to more than $3,000 in modern currency. To put that in perspective, The average American worker earned less than $2,000 per year at that time. A single Thompson cost more than a month's wages for most families. The weapon required extensive machining. The receiver had to be milled from a solid block of steel. The bolt required precise grinding to fit the locking surfaces. The wooden stock had to be shaped and finished by hand. The entire process demanded skilled labor and specialized equipment. It took too long to manufacture and consumed too much steel, too much time, too many man-hours that could have been spent building tanks or aircraft or ships. Even after the Army simplified the design and created the M1A1 variant, the Thompson still cost $45 per unit by February of 1944, and the Army needed submachine guns, lots of them, more than the factories could produce. Paratroopers needed them for the close quarters fighting they would encounter after landing behind enemy lines. A paratrooper jumping into combat could not carry a full-length rifle. He needed something compact, something that could be brought into action immediately after landing, something that could spray automatic fire in the chaotic first moments of an engagement. Tank crews needed submachine guns for personal defense if their vehicles were disabled. The cramped interior of a Sherman tank left no room for a rifle. A tanker who had to bail out of a burning vehicle needed a weapon he could grab and use instantly. Officers and non-commissioned officers needed submachine guns for the brutal house-to-house combat that characterized modern warfare. Clearing a building with a bolt-action rifle was suicide. You needed firepower. You needed volume of fire. You needed a weapon that could dominate a room. The demand was overwhelming, and the Thompson simply could not be produced fast enough or cheaply enough to meet it. By early 1941, Army Ordnance officers had begun looking for alternatives. They studied foreign designs with growing interest. They examined the German MP-40, officially designated the Maschinenpistole 40, a weapon built largely from stamped steel parts that could be manufactured quickly and cheaply. The MP-40 had entered service in 1940 and was already being produced in enormous numbers for the Wehrmacht. German paratroopers carried it. Tank crews carried it. Squad leaders and platoon sergeants carried it. The American officers also examined the British Sten gun. The Sten was an even cruder weapon than the MP-40. It cost just $10 to produce. It looked like something assembled from plumbing supplies. The British called it the plumber's nightmare. The side-mounted magazine fed 9mm ammunition into a receiver made from a simple steel tube. The stock was a metal skeleton barely adequate to keep the weapon shouldered. The manufacturing process was so simple that resistance fighters in occupied Europe could assemble Stens in basement workshops. The Sten was ugly. It was uncomfortable to shoot. It had an alarming tendency to discharge accidentally if dropped or bumped. But it worked. It killed Germans. And it could be manufactured by the thousands in converted factories across England, by workers who had been making sewing machines or bicycle parts before the war. The Americans needed something similar, a weapon that was cheap, simple, and effective, a weapon that could be built by workers who had never touched a firearm in their lives, a weapon that could be stamped out on assembly lines like automobile headlights or coffee cans. Colonel Rene Studler was the man who would make it happen. Studler was the chief of the Small Arms Division in the office of the Chief of Ordnance for the United States Army. He had been born in Bluffton, Ohio, a small town in the northwestern part of the state, on February 10, 1895. He had graduated from Ohio State University in 1917, just as America was entering the First World War. He had earned his pilot wings training with the Royal Flying Corps in Canada, then served as a flying instructor at air service schools in Texas and Oklahoma. After the war, Studler could have returned to civilian life like most of his fellow soldiers, but something about military service had captured him. He was fascinated by the weapons and equipment that armies used. He wanted to understand how they worked. He wanted to make them better. In 1922, Studler transferred from the Air Service to the Ordnance Department. He completed a 2-year course at the Ordnance School of Application at Watertown Arsenal, which included studies at the Massachusetts Institute of Technology. He learned metallurgy. He learned ballistics. He learned manufacturing processes. He learned everything there was to know about small arms design. Over the next 2 decades, Studler rose through the ranks of the Ordnance Department. He served at Aberdeen Proving Ground, testing and evaluating new weapons. He commanded ordnance units in the Philippines. He developed new types of armor-piercing ammunition. By 1940, he had become the Army's foremost authority on small arms, a position he would hold for 13 years. In October of 1942, Studler initiated the development study that would lead to a new American submachine gun. The specifications, recorded as Ordnance Committee, Minutes 19007 on October 8 of that year, were demanding but clear. The weapon needed to be sturdy enough to survive the brutal conditions of combat. It needed to be manufactured rapidly and inexpensively, using methods that did not require skilled labor or specialized equipment. It needed to be quickly disassembled for cleaning by soldiers with minimal training. It could not utilize critical wartime materials that were needed for other weapons or vehicles. The new submachine gun had to chamber the standard 45 caliber automatic Colt pistol ammunition already in use by the Thompson and the M1911 pistol. Using existing ammunition simplified logistics and ensured that soldiers could share ammunition with each other. The weapon had to hit a 6-foot square target at least 90 times out of 100 when fired from a standing position at 50 yards. It had to fire at a cyclic rate not exceeding 500 rounds per minute, and it had to be cheap, very, very cheap. Studler knew exactly who he wanted to design this weapon. George Hyde had established himself as one of America's most innovative firearms designers. After arriving from Germany, he had worked as a shop foreman at Griffin and Howe, learning how Americans thought about firearms while repairing and customizing weapons for wealthy sportsmen. But Hyde was not content to merely repair and customize weapons for wealthy customers. He was a designer at heart. He wanted to create. In the late 1920s, Hyde formed his own company, the Hyde Arms Company, and began designing submachine guns. His first effort was the Model 33, a prototype that showed promise but needed refinement. This evolved into the Model 35, which the Army tested at Aberdeen Proving Ground in the summer of 1939. The test results were encouraging. The Hyde model 35 had several significant advantages over the Thompson. It was lighter, it was simpler, it was potentially cheaper to manufacture. But it also had some durability problems that concerned the evaluators. The test board recommended further development. Hyde could have stayed to fix those problems, but he had already seen where the future of weapons manufacturing was heading. The age of hand-fitted, precisely machined firearms was ending. The age of mass production was beginning, and Hyde wanted to be part of it. By 1941, Hyde had become the chief gun designer for the Inland Division of General Motors. Yes, that General Motors, the automobile manufacturer, the company that made Chevrolets and Buicks and Cadillacs. During the war, General Motors converted much of its production capacity to military equipment. The Inland Division, based in Dayton, Ohio, was assigned to manufacture M1 carbines, the lightweight rifles that would become one of the most produced American weapons of the war. When Studler came looking for someone to design a new, cheap submachine gun, Hyde was the obvious choice. He had the design experience, he had the manufacturing knowledge, and he was already working at a company with the industrial capacity to produce weapons by the hundreds of thousands. Studler paired Hyde with Frederick Sampson, the chief engineer for General Motors' Inland Division. Sampson was not a weapons designer, he was a manufacturing engineer. His expertise was in figuring out how to build things quickly, cheaply, and in enormous quantities. His job would be to take whatever Hyde designed and figure out how to produce it on an industrial scale. The collaboration between Hyde and Sampson was a marriage of genius and practicality. Hyde understood weapons. He knew what made a submachine gun function reliably. He knew the stresses that combat would place on every component. Sampson understood production. He knew what manufacturing processes were available. He knew what materials could be obtained. He knew what workers could be trained to do. Together they would create something that neither could have achieved alone. They would later file a joint patent for their creation, number 2403306, on May 1, 1944. Hyde's first design was designated the T-15. It was an all-metal weapon with a sliding wire stock, chambered in .45 caliber. The original specifications called for a select fire capability, meaning the weapon could fire either single shots or fully automatic bursts at the shooter's discretion. But when Studler reviewed the specifications in October of 1942, he made a crucial decision. He eliminated the select fire feature. The new weapon would be fully automatic only. The revised design was designated the T-20, reflecting both the elimination of semi-automatic fire and the addition of 9mm parabellum conversion capability. This was not a compromise. It was a deliberate design choice. A select fire mechanism required additional parts, additional machining, additional complexity. Every extra component was another point of potential failure. Every extra operation was another step in the manufacturing process that could slow production. The soldiers did not need select fire. In combat, submachine guns were used at close range, in situations where volume of fire mattered more than precision. A soldier clearing a building did not need to carefully aim each shot. He needed to fill a doorway with bullets as quickly as possible. Hyde and Sampson worked at a pace that would have been considered impossible for any traditional weapons manufacturer. The army had given them an urgent deadline. The soldiers needed weapons now. There was no time for the leisurely development process that peacetime weapons programs enjoyed. In just 2 months, they had a working prototype. The T-20 was unlike anything the American military had ever seen. It was ugly. There was no other word for it. The stamped steel construction gave it a crude, industrial appearance. The wire stock looked flimsy. The overall profile resembled a mechanic's tool more than a military weapon, but it worked. The weapon was constructed almost entirely from stamped sheet steel. 2 halves of the receiver were pressed from flat metal sheets and then spot welded together. The process was similar to how automobile body panels were manufactured. Press a flat sheet of steel into a die, and it emerges with the desired shape. Weld 2 shaped pieces together, and you have a completed component. The only parts that required any significant machining were the bolt and the barrel. The bolt needed to be heavy enough to operate reliably and precisely enough to chamber ammunition consistently. The barrel needed to be rifled to spin the bullet and ensure accuracy. Everything else, the trigger, the rear sight, the cocking handle, the magazine housing, could be stamped out on the same presses used to make automobile parts. This was not a coincidence. Studler had deliberately chosen General Motors' Guide Lamp division to manufacture the new weapon. Guide Lamp was located in Anderson, Indiana, about 50 miles northeast of Indianapolis. Before the war, the factory had made headlight assemblies for General Motors automobiles. The workers there were experts at stamping, forming, and welding sheet metal. That was exactly what the new submachine gun required. The workers at Guide Lamp had no experience making firearms. They did not need any. The T-20 had been designed specifically so that workers who knew nothing about guns could build it. The assembly process was broken down into simple steps that could be performed by anyone with basic manufacturing skills. In November of 1942, 5 prototype T-20s were sent to Aberdeen Proving Ground in Maryland for testing. Representatives from the Infantry Board, Airborne Command, and Armored Forces Board all evaluated the new weapon. They subjected it to the most brutal tests they could devise. They fired thousands of rounds through each gun, far more than any soldier would fire in actual combat. During accuracy testing, the prototypes achieved 97 hits out of 100 on a 6x6 foot target at 50 yards. They fired over 5,000 rounds with only 2 feeding failures. They dragged the weapons through mud, coating every surface with thick, wet clay. They buried them in sand and then tried to fire them. They dropped them from heights onto concrete. They froze them and baked them and soaked them in salt water. The T-20 passed every test. In mud and sand trials, it performed better than any other American submachine gun ever tested. The fully enclosed operating system kept out dirt and debris that would have jammed other weapons. The generous tolerances, which critics had worried, would make the weapon inaccurate, actually improved reliability by allowing the action to cycle even when fouled with grime. On December 12, 1942, the T-20 was officially adopted as the United States submachine gun, caliber 45 M3. The designation was simple. M stood for model. 3 indicated that this was the 3rd model of submachine gun adopted by the Army. The M1 and M1A1 Thompsons were models 1 and 2. The new stamped steel weapon was model 3. The contract for production was awarded to Guide Lamp Division. The unit price was set at $18.36 for the receiver and components, with an additional $2.58 for the bolt assembly, which was subcontracted to Buffalo Arms Corporation. Total cost per weapon, $20.94. Even the simplified Thompson still cost $45. The M3 cost less than half that amount. The American military had achieved an unprecedented reduction in the cost of a submachine gun. The entire development process, from Studler's initial requirements in October to official adoption in December, had taken just 2 months. No other firearm in United States military history has ever been designed, tested, and put into production so quickly. Production began in May of 1943. Guide Lamp's workers, many of them women who had never worked in manufacturing before the war, began assembling weapons on the same production lines that had once built headlights. The factory ran around the clock. 3 shifts of workers kept the presses stamping and the welders sparking, and almost immediately everything went wrong. The first production run was a disaster. Inexperienced workers applied too much heat while welding the receiver halves together. The excessive heat warped the thin sheet metal, causing the frames to twist out of alignment. A warped receiver meant the bolt would not travel smoothly. The weapon would jam, or fail to feed ammunition, or refuse to fire at all. Inspectors at the factory began checking every weapon before it left the production line. They rejected gun after gun after gun. Nearly the entire first production lot, almost 20,000 weapons, had to be scrapped due to improperly aligned receivers. By July of 1943, only 900 M3s had passed inspection, far short of the projected 20,000. It was a catastrophic setback. The Army desperately needed submachine guns. The invasion of Europe was being planned. Soldiers were training for combat with weapons that did not exist, and the factory that was supposed to produce those weapons was turning out defective units by the thousands. But Guide Lamp learned. The workers adjusted their welding techniques, using less heat and more precision. Quality control procedures were implemented at every stage of production. Engineers redesigned fixtures to hold the receiver halves in perfect alignment during welding. Supervisors were assigned to monitor critical operations. Slowly, the rejection rate dropped. The weapons began passing inspection. By the end of 1943, Guidelamp had produced 85,130 M3s, not the numbers the Army had hoped for, but enough to begin issuing the new weapon to combat units. In 1944, with the production problems solved, output soared. Guidelamp delivered 343,372 M3s that year. The factory that had struggled to produce working weapons just months earlier was now manufacturing them by the thousands every week. The soldiers who received the new weapon were not impressed. The M3 was ugly. There was simply no way to describe it otherwise. The stamped steel construction gave it a cheap industrial appearance that offended soldiers who were used to the beautiful machined surfaces of the Thompson. The wire stock felt flimsy compared to the solid walnut of the Tommy gun. The crude cocking handle, a stamped lever on the right side of the receiver, looked like it would break off if you looked at it wrong. Some soldiers reportedly held the M3 in mild contempt, considering it a cheap knockoff of the German MP40. The soldiers called it names: the plumber's nightmare, the cake decorator, the oil can. But the name that stuck was simpler and more descriptive. The weapon bore an unmistakable resemblance to the grease guns used by automobile mechanics to force lubricant into chassis fittings. The cylindrical receiver, the pistol grip, the overall profile, all suggested that tool. So that is what the soldiers called it: the grease gun. The nickname was not meant as a compliment. Don Burgett was a paratrooper with the 101st Airborne Division, serving with A Company, 1st Battalion, 506th Parachute Infantry Regiment. He would later write a celebrated memoir of his wartime experiences, titled Currahee. His opinion of the M3 was blunt. He reportedly called it a piece of junk. Many soldiers in the 82nd Airborne shared that assessment. If given a choice between the grease gun and the Thompson, almost everyone chose the Thompson. The Tommy gun was proven, it was reliable, it looked like a real weapon. The grease gun was cheap, and it looked cheap, and soldiers did not trust their lives to cheap equipment. But the M3 had one advantage that no amount of skepticism could deny. It was there. The Thompson was in short supply. Production could not keep pace with demand. Soldiers who wanted Tommy guns had to wait. Soldiers who accepted grease guns could go into combat immediately. And when you are about to jump out of an airplane into enemy territory, any weapon is better than no weapon at all. June 6, 1944, D-Day, the day the Allies returned to France. The M3 made its combat debut in the hands of paratroopers from the 82nd and 101st Airborne Divisions. In the darkness before dawn, thousands of American soldiers jumped into the black skies over Normandy. They carried everything they would need to survive behind enemy lines until reinforcements could arrive from the beaches. Rifles, ammunition, grenades, rations, medical supplies. Some of those soldiers carried the new grease gun. The M3 had several advantages for airborne operations. It was compact. The wire stock folded against the receiver, reducing the overall length to just 22.5 inches. It did not need to be disassembled before a jump like the M1 Garand, which had to be carried in a padded bag to prevent damage. The grease gun could be put into action immediately after landing, ready to fire the moment the paratrooper hit the ground. For soldiers who might find themselves fighting within seconds of landing, tangled in parachute lines, surrounded by enemy troops, these were significant advantages. Captain Bob Piper of the 505th Parachute Infantry Regiment, 82nd Airborne Division, was photographed in front of a wrecked hawser glider somewhere in Normandy. In his hands was an M3 submachine gun. Piper had carried the grease gun into combat on the most important day of the war. He had trusted his life to the cheap stamped steel weapon that other soldiers mocked. The fighting in Normandy was brutal beyond anything the soldiers had experienced in training. Paratroopers scattered across the countryside, often landing miles from their intended drop zones, had to fight their way to their objectives through hedgerow country, where every field was surrounded by dense earthen embankments, topped with impenetrable vegetation. The hedgerows created a maze of enclosed spaces, perfect for ambushes. German defenders could hide within feet of advancing Americans and remain invisible until they opened fire. The M3 proved itself in these close-quarters engagements. At ranges measured in yards rather than hundreds of yards, the grease gun's limitations did not matter. The heavy .45 caliber bullet hit hard. The slow rate of fire, just 450 rounds per minute compared to the Thompson's 700, was actually an advantage. It made the weapon easier to control. Soldiers could fire short bursts without emptying their 30-round magazines in seconds. A paratrooper with the headquarters of the 501st Parachute Infantry Regiment was photographed during the invasion taking a bite from a Norman apple. Cradled in his lap was an M3. He had removed the wire stock, making the weapon even more compact for the close fighting in the bocage. As the weeks passed and the campaign progressed from Normandy into the heart of France, reports began filtering back to the United States. The soldiers' initial skepticism was giving way to grudging acceptance. The grease gun might be ugly, but it worked. It killed the enemy. And when your weapon does what you need it to do, cosmetics become irrelevant. An Army Combat Observations report dated February 5, 1945, detailed what small unit leaders in the 99th Infantry Division thought of their new close combat firearm. The M3 submachine gun is the best weapon we use for patrolling, they reported. It can be put into action quickly. At short ranges, it is accurate and powerful. Staff Sergeant J.W. Logan of Company D, 101st Infantry Regiment, 26th Infantry Division went further in his assessment. He suggested that every machine gun squad leader should carry a submachine gun rather than the M1 rifle. The grease gun was winning converts, but even as soldiers began to appreciate the M3, problems were emerging that threatened to undermine confidence in the weapon. The most serious issue was the cocking handle. The M3 was designed with a crude, stamped lever on the right side of the receiver that the soldier pulled back to cock the weapon. This lever was necessary because the bolt was too heavy to be easily retracted by hand. You grabbed the handle, pulled it back against spring pressure, and released it. The bolt would lock to the rear, ready to fire. The problem was that the cocking handle was fragile. It was made from thin stamped steel, attached to the receiver by a simple pin. Reports of failures began arriving as early as February 1944, first from stateside training units, then from forces preparing for the invasion in Britain. If the gun was dropped or bumped the wrong way, the handle could shear off completely, and once the handle was gone, there was no way to retract the bolt. The weapon was useless. During the closing months of 1944, as American soldiers fought their way across France and into Germany, reports of broken cocking handles began arriving with alarming frequency. Soldiers dropped their weapons while running. They knocked them against walls while clearing buildings. They set them down carelessly and heard the sickening crack of metal breaking. The Army's ordnance companies were equipped to repair almost any infantry weapon in the inventory. Armourers could fix jammed rifles, replace worn barrels, rebuild damaged triggers, but they could not fix the grease gun. In the rush to develop and adopt the weapon, the vulnerability of the cocking handle had been overlooked. There were no spare cocking handles. There was no prescribed repair procedure. The weapon had been designed to be disposable. If it broke, you were supposed to throw it away and get a new one. That philosophy worked fine in peacetime procurement planning. It did not work for soldiers fighting deep inside enemy territory who could not simply walk to an armory and request a replacement weapon. The soldiers improvised. In Patton's Third Army, ordnance personnel developed a field expedient that would keep the M3 fighting. They removed the fragile ratchet components entirely, then milled a slot into the top of the receiver at about the 2 o'clock position, exposing the bolt beneath. They drilled directly into the bolt and attached a rigid charging handle using whatever materials were available. The soldier could then pull back on this improvised handle, which travelled through the slot to cock the weapon. It was ugly. It was unauthorized. It would have horrified the engineers who designed the weapon, but it worked. Archival photographs from the Battle of the Bulge show grease guns modified in exactly this manner. The Musée National d'Histoire Militaire in Diekirch, Luxembourg, has 5 M3s in its collection that received this field modification. All of them were carried by soldiers of Patton's Third Army during the bitter winter fighting of December 1944 and January 1945. Meanwhile, back in the United States, engineers at Guidelamp were already working on a proper solution. The improved model was designated the M3E1, with E standing for experimental. The most significant change was the complete elimination of the troublesome cocking handle. Engineers realized that the handle was unnecessary. The bolt of the M3 was heavy, but not so heavy that a soldier could not retract it with finger pressure alone, if only there was a way to grip it. The solution was elegant in its simplicity. Engineers machined a large cylindrical hole directly into the bolt. This finger hole allowed the soldier to insert an index finger, grip the bolt directly and pull it back against spring pressure until it locked. No external lever was required. Nothing could break off. The cocking mechanism was now part of the bolt itself. The design was described as simplified and indestructible. Additional improvements were incorporated into the M3A1. The ejection port was enlarged to accommodate the finger hole operation. The rear sight was strengthened. The wire stock was redesigned to serve double duty as a barrel wrench and cleaning rod. The M3A1 was officially adopted on December 21st, 1944. Upon adoption, the original M3 was reclassified as Limited Standard. The improved version was even simpler than the original, even cheaper, even more reliable, but it arrived too late to see significant combat service in World War II. Only 15,469 M3A1s were manufactured before the war ended. Total wartime production of the M3 reached 606,694 units. Combined with the M3A1s, the Guide Lamp factory in Anderson, Indiana, produced more than 622,000 submachine guns during World War II. Thompson production, for comparison, reached approximately 1.7 million units across all variants and manufacturers. The Thompson still outnumbered the grease gun, but the grease gun had proven itself in combat. And when the Korean War began in 1950, the Army knew exactly which weapon to send. What happened next would have seemed impossible to the soldiers who had mocked the grease gun as a piece of junk. The ugly little weapon refused to die. The Korean War erupted on June 25, 1950, when North Korean forces crossed the 38th parallel and invaded South Korea. American troops were rushed to the peninsula to halt the communist advance. Many of them carried M3A1 submachine guns. By this time, the initial production problems had been solved. The M3A1 was the standard variant, with its finger hole cocking mechanism and improved reliability. Soldiers who had despised the original M3 discovered that the improved version was actually quite effective. The Korean War was fought in conditions very different from the hedgerow country of Normandy or the forests of the Ardennes. Korea was mountainous. The fighting alternated between sweeping maneuver operations across rugged terrain and brutal close quarters, combat in villages, and fortified positions. Both situations favored the compact M3. The slow rate of fire, which critics had initially seen as a weakness, proved to be an advantage. Korean War veterans reported that the M3 was much easier to control than faster firing weapons. You could place your shots more precisely. You consumed less ammunition. You stayed in the fight longer. Alan Archambault, former supervisory curator for the United States Army Center of Military History and former director of the Fort Lewis Military Museum at Joint Base Lewis-McChord near Tacoma, Washington, later observed that by the Korean War, the M3 and M3A1 were used in greater numbers than the Thompson. The weapon the soldiers had mocked had outlived its legendary predecessor. During the Korean War, Ithaca Gun Company manufactured an additional 33,200 M3A1s, bringing total production of that variant to 48,669 units. The M3 continued its service in the years that followed. It became standard equipment for armored vehicle crews. The compact size was ideal for the cramped interiors of tanks, where there was no room to maneuver a full-length rifle. Tank crews appreciated having a weapon they could grab quickly if they had to bail out of a disabled vehicle. Vietnam came next. The M3A1 proved particularly useful in the jungles of Southeast Asia. The fully enclosed operating system kept out the moisture and debris that jammed other weapons in the humid tropical environment. Helicopter crews carried grease guns as emergency backup weapons in case their aircraft was shot down in hostile territory. The Office of Strategic Services, forerunner of the Central Intelligence Agency, had developed suppressed versions of the M3 during World War II. Bell Laboratories designed the suppressor, which screwed onto the barrel and reduced the weapon's report to a barely audible click. In Vietnam, these suppressed M3s found new users among special operations forces conducting covert missions behind enemy lines. The 45 caliber round was naturally subsonic, meaning the bullet traveled slower than the speed of sound. This was important for suppressed weapons. A supersonic bullet creates a loud crack as it breaks the sound barrier, regardless of how quiet the gun itself might be. The subsonic 45 caliber round produced no such crack. With a suppressor, the M3 was almost silent. Delta Force, America's elite counter-terrorism unit, formed in 1977, initially equipped its operators with M3A1s fitted with suppressors. The unit's founders reportedly prized the weapon for its impressively quiet performance. Within a year, most operators had transitioned to the more modern Heckler & Koch MP5, but some operators kept their grease guns, believing that the old weapon actually performed better with a suppressor than the new German design. The irony was not lost on those who understood the history. A weapon designed by a German immigrant was being judged superior to a weapon built by one of Germany's most prestigious firearms manufacturers. Decades passed. The Cold War reached its peak and then began to thaw. The Berlin Wall fell in 1989. The Soviet Union collapsed in 1991. The threat of nuclear war between superpowers receded into history, and still, somewhere in the American military inventory, grease guns remained in service. In January of 1991, the United States launched Operation Desert Storm to liberate Kuwait from Iraqi occupation. The campaign showcased the most advanced American military technology of the era. F-117 stealth fighters struck targets with precision-guided munitions. Abrams tanks equipped with laser rangefinders and thermal imaging systems dominated Iraqi armor. Patriot missiles intercepted Scud ballistic missiles in flight, and in the vehicles of the 19th Engineer Battalion, attached to the 1st Armored Division, soldiers still carried M3A1 submachine guns as part of their standard table of organization and equipment. The last time the grease gun went to war as an official member of the United States military inventory was Desert Storm in 1991. Nearly 50 years after George Hyde sketched his first designs, the cheap stamped steel weapon was still there. There was no single retirement date for the M3. The weapon was officially classified as obsolete by 1957, but it remained in vehicle inventories for decades longer. A Stars and Stripes article from August 2008 mentioned that the M4 carbine was finally replacing the M3 submachine gun for certain personnel categories, including vehicle crews, radio operators, and combat engineers. One former tank company commander reported 2 M3A1s in his unit arms room as late as 2001. The Japanese Self-Defense Forces used M3s until 2011, when the last of them were finally retired after decades of service. Philippine Marines still carry them today. More than 60 years of service from a weapon that cost $20.94 to manufacture. George Hyde did not live to see his creation serve through the Cold War and beyond. He died at Adelphi Hospital in Brooklyn, New York, on December 2, 1963, at the age of 75. His obituary in the New York Times emphasized his pivotal role in designing the M3 submachine gun, the weapon that had become an unlikely icon of American military efficiency. Hyde had never received the fame that John Thompson enjoyed. The Thompson bore its creator's name. Everyone knew what a Tommy gun was. The grease gun was just the grease gun, named for a mechanic's tool designed by a man whose name appeared in few history books. But historians who studied the weapon understood what Hyde had accomplished. He had taken the principles of mass production that Henry Ford had applied to automobiles and applied them to firearms. He had designed a weapon that could be built by anyone, anywhere. Using standard industrial equipment, he had proven that quantity could substitute for quality when the numbers were large enough. Frederick Sampson, the manufacturing engineer who had figured out how to produce Hyde's design using automobile factory equipment, continued working at General Motors after the war. His contributions to military production were largely forgotten outside of engineering circles, but the techniques he pioneered for manufacturing weapons from stamped steel components influenced firearms design for decades. Colonel Rene Studler, the ordnance officer who had brought Hyde and Sampson together and championed the M3 through the bureaucratic obstacles of military procurement, received the Legion of Merit for his wartime service. The citation praised his work, developing and increasing the firepower of numerous small arms while decreasing the weight carried by foot soldiers. Studler retired from the Army in 1953 after 13 years, directing American small arms development. He spent the next 25 years as a consultant to the military and defense contractors. He died of cancer on August 6, 1980, at the age of 85, and was buried in Arlington National Cemetery alongside his stepson, Lieutenant Commander Harlan R. Dixon, who had earned 2 Navy Crosses before being killed in action in 1943. The M3 they created together served longer than any of them could have imagined. It armed American soldiers in the last great battle against fascism. It fought communist expansion in Korea and Vietnam. It served with special operations forces in conflicts that remained classified for decades. It was carried by tank crews in the deserts of Iraq, half a century after its design. More than 600,000 M3s were manufactured during World War II. Additional production during the Korean War brought the total higher. The weapon was exported to allies around the world. Argentina manufactured its own version. China made copies. Taiwan made copies. The weapon that had been designed as a cheap, disposable alternative to the Thompson became one of the most widely distributed submachine guns in history. This is how industrial warfare actually works. Not through superior craftsmanship or elegant engineering, but through the relentless application of mass production to military problems. The nation that can produce the most weapons, distribute them the fastest, and replace them the quickest will ultimately prevail against an enemy that builds fewer weapons of higher quality. The MP40 was a better submachine gun than the M3 by almost any technical measure. It was more accurate, more reliable, better constructed, more comfortable to shoot. But for every MP40 that Germany produced, America could produce multiple grease guns, and multiple adequate weapons will defeat one excellent weapon every time. The M3 grease gun was never loved. Soldiers who carried it did so because they had no choice, not because they preferred it over the alternatives. The weapon was ugly, crude, and cheap. It looked like a plumber's tool. It felt like a toy compared to the solid heft of a Thompson. No soldier ever wrote home bragging about his grease gun the way they bragged about their Tommy guns, but it worked. It killed the enemy. And it could be manufactured by workers who had never touched a firearm before, using equipment designed to make automobile headlights at a cost of $20.94 per unit. The $20 gun that made German engineering irrelevant. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters, each one deserves to be remembered, and we would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you are part of something special here. Thank you for watching, and thank you for keeping these stories alive.